some technical problems, but let's go with this. So as you can see, I'm going to share my screen too. This one. Okay, so now you should see a screen with a web class in it. And as you can see in the in-class questions and new theme that I opened recently, today we're going to be talking about dictionaries, a little bit about lists, and we are going to be completing some part of the tasks that you need to do for programming project number 1. Having a look at the calendar, okay, let's see. Apart from several things from my household, we have 1 more week until the submission date. Okay, my apologies. The submission date was originally set up for today, but it's not. It's next week. So basically, you have 1 more week to complete project number 1. The deadline is next Monday at 11:59 at night. Please do not stay up late. Try to finish earlier. But basically, if you have many questions and so on, probably next lesson will already be too late. Okay, so my advice is that you do your best to complete whatever you have not yet completed during this week. Submit anything that you have that you want me to look at and give you feedback. Remember, you can submit as many times as you want. Okay, so if you send something today, I will do my best to look at it quickly and send it back to you so we can fix any possible mistakes. If you send that on the 19th at any time, probably I will not be able to give you that feedback. And if there is some misunderstanding, some problem, that will very likely affect your grades. Okay, this subject is only evaluated with these 3 programming projects, of which the one that we are submitting next week is the first one. So please remember to do this part of the job. So far, I have had some really nice submissions, but very few of them. So some people have really been doing excellent work and are mostly finished. The other people I don't know about. Okay, so be careful. This is not simple. This is not quick to do, especially if you haven't programmed before. Okay, you have had some time to get acquainted with it. If you plan on starting something next Monday, you will not succeed. Okay, it's very likely that you will not succeed. Maybe your programming is excellent, then I have absolutely no problem with whatever time management you want to do, but be aware that this is not simple coding. Okay, so take advantage of this remaining week to ask as many questions as you want. You can ask them today during the class at any moment, or just submit the thing, send me an email and see what problems you have and so on and so forth, and we can try to fix them. But don't wait until next week's Monday. That time it will likely be too late. Although during next session, I will do my best to introduce some of the next things that we are going to be looking at, but also to answer any questions about this. But they should be some very last minute, just quick fixes for something that should be mostly completed. Okay. Okay, back to it. Today we expect to be processing data, the same data that we have been talking about, using dictionaries. So I will use the project as an excuse to talk a little bit about dictionaries, hopefully a little bit about maps too, and also a little bit about tuples and lists. Okay, so I have set up like 2 sets of tasks for beginners and for slightly more advanced programmers, and I will read them now and then set up the notebook that I will be using to demonstrate all of these things. And then I will give you a few minutes to get acquainted with what you have to do, to think about it, 5 minutes, and then I will begin the proper explanation. So our goal is this one. We want to use dictionaries to find how many times every wind direction is repeated. Every wind direction in the data is repeated. Okay? And that's a question, like any of the questions that we have seen before, with quite a few layers. So first of all, we want to do what we had already done in previous sessions. We want to open the file, jump the first line using next, okay? Process each line using split, break each string corresponding to each line at the commas, and creating a list of strings. Okay, we had already done that. So we could print every line separately, for example, and break down every line into a list of strings that contained all of those wind directions, as well as the number for the line and the date that that data corresponded to. But in this session, we want to go over that list of wind directions in every line. So we do not want all of the line, but just a part of it. So we're going to be using a little bit of list slicing, very probably. And we want to add every wind direction to a dictionary. Okay, I will be speaking a little bit more about what dictionaries are, but we are going to be wanting to create a dictionary whose keys are each of the possible wind directions and whose values are, for each key, the number of times it is repeated. For example, if the direction capital W, which amounts for the west wind direction, is repeated 23,699 times, to say a number, we want to have a pair that has W, capital W as its key, and that number 23,689 as its value. Okay, that's what we will want to build. This can be solved in many ways. My initial suggestion was to first create a list of tuples. I will show you how to do that, okay? I think that's a way to break the problem into two that is natural for me. The good thing with programming is that everyone can solve problems in a different way. So if that works perfectly, if that doesn't work, don't be constrained by that suggestion in the text of the exercise. Okay, if you do this without needing the list of tuples, that's also okay. So that's what we want to do for beginners. Do what we had already been doing, open file, jump, break down each line into list of strings, and then build this dictionary. Okay, I'm not going to completely solve this, but I'm going to give you a very good head start. For the advanced students, well, I think here creating a tuple will help you quite a lot. And then we want to create a list of tuples by iterating all of these lines. We can do this with a loop, for loop, or a while loop, depending on how you're coding the opening of the file. And then we want to make this a little bit more compact. So first do this with a simple loop, then transform the loop into a function. And finally, if we have a function inside of the loop, we can get rid of it using a map. So today we can speak a little bit about how to use these maps to get rid of loops. Well, let me finish with points 2, 3, and 4, and then I will say something about Python programming and maps. Once you have this list of tuples that contains the contents for every one of the lines, you can create a dictionary. And my recommendation is to use not a simple dictionary, but a default dict. Okay. If you create that dictionary, and today we will see a little bit of that, you will see that there are some values that are incorrect or at least weird. And you have to decide what you do with those and clearly explain what you have done in your submission. Then I have this. I'm not sure if we will have time to get into it, but you should use maps and probably the count function. You probably want to look into the stack function because we have many columns, but in general, we don't care what time, in this case, what time every wind direction happened. So you can just stack everything into one big single column. And then you can use value counts or counts from pandas to count how many times every direction happens and to put that into a dictionary. Improve the code as much as you can using maps. I mean, the first one, not the pandas one. And then you should measure the time for the three options with a simple loop, with pandas, and with maps. Okay, that's what we want to do today. We have the code for the project here. Let me create a copy in my drive, for example. And I will call this something different because this is the file that I will be using to do the explanations today, okay? I'm going to call this improc masters session 3, okay? And then in a few minutes, I'm going to be speaking about this. What did we already do? Well, first of all, sorry, yeah, this is fine. We download the data to the Colab machine. Remember, this is not my computer at this moment. I'm opening a browser in my computer and that's running something in a computer that belongs to Google. So I'm downloading the data there. And now that I have run this cell, I can see it here, okay? Initially, I downloaded this as an Excel file and then break down this Excel file, each of these sheets at a different CSV file, okay? And now in a second, I will be able to see all the files, and I want to process the windDirection file. That looks like this. Let's show more results per page. This is par for the course, okay? I've done this quite a lot of times. Let me see if I can get so from this data, we already said it a little bit, but many of the data is missing. So we have to do something about that. How will that be processed? How will that look? Okay, let me go to page 40. We have lots and lots of data. Okay. Okay, at this moment, I cannot see any clearly wrong data, but we will find them later. Here, all the data looks very uniform. Okay, apart from the blank lines, everything is either east, west, north, east. It's quite clear. But unfortunately, there are some, let's say, imprecisions or errors in this data. There is a fact that the later hours of the day from something like 6 are way less recorded. I assume people were not working at this day, at this hour of these days. But the second problem is that all of these things were input manually. And that resulted in many, many errors. Not many errors, but a few errors, okay? There are over 4,000 lines here with 15 recorded entries on average, which means that that's a lot of typing. And at some point, I think this was initially recorded like in paper by someone. And then at some point, this was translated into these Excel files, but by a group of very hardworking students from the forestry research group in the Faculty of Agriculture, which means that someone had to spend a long time translating from paper to Excel, and that is necessarily prone to errors. But what I want to tell you here is that that is not an oversight from them or from me or something that's infrequent at all. Okay. Sometimes when we do these programming classes, we tend to give the data already cleaned up for the students to focus on the newer and fancier programming things and so on. But in this course, you have different profiles and you come from different places. And one thing that all of them will share is that anytime that you start doing a code project, you will have this problem. Any real world data will have these imprecisions, these unexpected things that you have to figure out and to work with. Okay, so that's why we left them in. And today we will see how they affect. And I think, well, I was thinking there was something clear, some clearer here. It's not there, but that in itself is not bad. If I look at the data, if I open a couple of pages or three, okay, let's open page 30. The data looks great. We see this clear problem of the white spaces and so on, but it's not like it's full of errors or anything. So even a more or less detailed visual inspection, we do not find major problems. So we might think that this data have already been cleaned up and so on. It will not be until we have already processed most of the data that we realize with some of the problems that some of you have already pointed out. Okay, this data processing process is also has also feedback loops built into them. Hopefully, in your data science projects, you will work together with the people who collect the data, because sometimes when you are halfway of a project, you realize that what you have done until that point has some problem that needs to be fixed, and then sometimes that means working a little bit more on the annotation of the data, and sometimes, unfortunately, even in the collection of the data. Okay. So data science projects should happen in teams. Everyone should bring something different to the table, and you should bring the capacity not only of creating code to do fancy things with the data, but also understanding the particularities of the data and how to ask for what you need from other team members. Okay, that's my particular high horse and my particular proclivities about data and what it really means to work with them. Okay, sorry, I will give you now, as I promised, 5 minutes to get acquainted a little bit with these tasks. Okay, remember what we said before. Meanwhile, I'm going to just set up the initial, well, I already have it. I have the file downloaded and so on. I will just set up the initial loop in a second, and in 5 minutes, we will start solving this. So please have a look. We have 1 more minute, and then we will start the explanation about dictionaries. Okay, so let's go. As you maybe already saw before, I basically repeated what we had done last time. So I opened the windDirection file, jumped the first line with next, the one where we have the names of the columns, and then I just printed every line. Okay, so now we will start using dictionaries and using other techniques. But before of that, let's have a look at what that means. So this part is about data structures, okay? And if you want to know more about that, you should check course number 2, which is helpfully, although maybe not imaginatively named, data structures and complexity. We will not be speaking about complexity, but now that I see it, I remember that I said I would say something about maps before. Complexity in programming usually deals with how many steps your algorithm does, not having too many loops, finding efficient ways to find things, to solve problems, not having to wander over the search space of your problem, not having to repeat things too many times. That's the complexity part of this course, which I will not be discussing here, but that you can have a lot of information about here if you are so interested. And that's the most classical way of making your code faster and more effective. And faster is not only nice because things take shorter, but also because in today's world where data is very huge, having faster algorithms is often the difference between being able to do something or not being able to do something, because maybe your computer will take years to complete a calculation, and if you use an optimal algorithm, that can be just a few minutes. Okay, so you want to know about fast code, you have this course, which you can freely have a look at. If you have any questions, you can ask me. We will not discuss them in this subject. But the second way to make your code faster is to use parallel programming. That used to be quite complicated, but the Python programming language lends itself very naturally to that. There are quite a few parts of the Python programming language that are parallel by default, and that's user transparent. So even you don't know you're actually coding things that work in parallel. What do I mean by work in parallel? Nowadays, our computers usually have more than one processor in its CPU, okay? So that means that our code can do the same thing repeatedly, and they can all run at the same time. That also results in faster code. Not from the point of view of complexity, but it actually does take shorter time. In Python, in short, you should avoid general loops as much as you can. I know a couple of weeks ago, I told you about loops and how these are very useful and very flexible to solve many different problems, and we are using a loop now. But if you want to make your code faster, you need to learn some of Python's techniques to actually get rid of those loops. List comprehension and dictionary comprehension are one of those, and the most well-used one is maps and functional programming. Maps, filter, reduce. So today we will see just a little bit about that too. But the course is mainly about data structures. So first of all, I wanted to just quickly have a look at lists. We have already been using quite a lot of lists, okay? But if you want to know more, if there is something that's not clear, you have all of this unit here, from the way of defining an empty list to the ways of accessing lists. In Python, things are always indexed from 0 to length -1, okay? And you can also index things negatively. So the last position is -1 because -0 is not a thing. And then it goes down from there, -2, -3, -4, -5, okay? We have some examples of how to access lists in this way here. And we also have examples of some of the functions in list. Append, we have the whole thing where lists are mutable, which you can have a look at. We already saw how to iterate list, how lists were iterable, and we can do for that go overall list. We also saw how to search and traverse in lists very quickly, but you have many repetitions here. And we also have some examples of list slicing in this code. List slicing is where you do not use the whole list, but using these properties of indices and the range function that we use in loops, you can select just some part of the list, okay? And I will be doing that a little bit today. Okay, so that's for lists, which again, we have already used and will use today, but you can already have a look at. Mentioned list comprehensions, those are in course 3 and here, some advancing programming techniques, and then you have some discussion about what is more efficient, list comprehension or for loop, okay? So you can have a look at those, course 3, unit 3, and the following example. Okay, we wanted to speak about dictionaries. Dictionaries are another type of data structure. Data structures are just, well, structures that we use to keep data, as the name indicates. But each data structure has a different goal. The list data structure implements the sequence of elements. And what we want to do is use this inherent structure of the data. They come one after the other in order to access the elements conveniently and very quickly. In dictionaries, we have data that doesn't have an inherent structure. There is no first element, second element, third element. We don't often even know how many elements we are going to have in our data. So we need a different type of data structure. And what we use very frequently is this dictionary data structure. When I mention the word dictionary, naturally, most of you will think about words dictionaries. I still make the gesture of the book, even though nowadays everyone checks their dictionaries on their either computer or mobile phone, okay? One of these words dictionary, English dictionary, is effectively a dictionary, and you can implement them in Python. How does a words dictionary work? Well, you have syntax, a sequence of characters for each of your words. You have T-A-B-L-E for table, and that's the identifier of that concept. That's the key that allows me to store that piece of information. And then I have its value, its definition. A table is a piece of furniture, usually with 4 legs, that blah, 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 blah. We have a long definition there. So we have these two parts, sorry. On the one part, we have the key, which is the name of the word, the sequence of characters that identify the word, and then we have a value, which is the definition of that word in a English language dictionary, for example. But that's not the only type of dictionary that's around, okay? We used to have yellow pages. Yellow pages were a type of dictionary where you had someone's name or someone's phone number as their key. So the key could be either another sequence of characters or a sequence of numbers, and then the value was the address of that person or business. The travel cards that we use, at least in Japan, most often, that's a card Suica, for example, that when you enter public transportation, a bus or a train or a metro, you read with a scanner there. That is also a dictionary. The key there is the number embedded in that card, and then that goes together with lots of information about how much money you have, your name, probably if you have given their name, your address, your travel history. So in that case, the key is a number, and the value that goes together with that number is all of that other information, number of trips, money left, and so on and so forth. So dictionaries in Python are always this data structure that puts together these two worlds of keys and values in one single data structure. The values are the information that we want to store, that we want to use, that we want to process. And the keys are some convenient way of sorting them out. The sequence of characters, the name of each word in a dictionary allows me to put them in order, because once I have two sequence of characters, I can know which one goes first. So even though my values, my information may not be sorted, my keys allow me to sort things and to sort them in an efficient way. And even if there are many possible words in my dictionary, possible keys in my dictionary, I can always group together the ones that I have and have them sorted easily and properly. Okay. So inside of my dictionary, I'm going to have pairs, key value pairs. Each key will be associated with one value. And my dictionary will be this kind of soup of pairs. And if I have chosen my keys properly, I will be able to find the key that I'm looking for very quickly. Okay. I could store everything in a list. I could put all of these key value pairs in a list. That would be totally possible. And you have some code that does that in this unit. And I heartily recommend that you go and check it. Okay. So I could store everything in a list and everything would work. I could do all the same things that I do with dictionaries. But searching in a list, as we saw last time, implies looking at all the elements in that list. With dictionaries, if I build them correctly, searching for one key and value pair will not need to check all the values, but I will be able to very quickly go and find the key and value pair that I want to find. Okay, dictionaries are actually quite complex to build, but luckily for us, that comes pre-made with Python. So we only have to say dictionary, and Python will do its magic and will give us a data structure that can, under the hood, be quite complex, but that does this, that stores key and value pairs and allows us to add them and access them very, very quickly. Okay. One final word regarding dictionaries before we go and actually use them is that the key value pairs are unique. So each key can only be associated with one value. If I add a key that I already have to a dictionary, if I now add another pair, key 35, and value something else, this will effectively erase this pair. It will go find this key, get rid of this, and put in the new value. Each key is associated with one and only one value. Okay, that's the way dictionaries work. If I really want to do keys that can be associated with different values, then I can cheat out of this a little bit, and what I can have is a key with a value that's actually a list and that has different things inside of it. That's possible. Okay, but I cannot have the same key twice. Okay, I have the key once and usually one value, and maybe this value is a list and I can add different things inside of it. Yeah, no problem. But the key can only be present once in the dictionary. Okay, and as I was saying, here we have some functions to iterate dictionaries, to check different types of dictionaries, and we have some code to check the efficiency of dictionaries and lists. And I recommend that you have a look at it, but basically searching in a list requires looking at all possible elements in the worst case, and that's way slower than just using dictionaries. So let's go and do that. Let's go and use dictionaries. Okay. So sorry, excuse me. The first thing that we want to do is we were saying we want to create a list of tuples. Tuples are just aggregations of values. Okay, I'm not going to stop too much on them, but you also have them here. Okay, you can have a look at that too. But basically, I'm going to just split every line like we had already done before. And I'm going to creatively name this split line. And I split it using Python's split at the commas. Okay, and then I can, if you want, print this. If I do this, split line. Okay. Instead of having a string for every line element, what I have now is, well, a list, as I was hoping for. Okay, this list has several values. This is position 0, 1, 2, 3, and so on and so forth. And as we saw last time, it has this new line character here in the last position. So I'm going to be splitting actually not line, but line strip function. Get rid of these blank or new line characters either in front of a string or at the end of the string. Okay, doing that, I got rid of all of these new line characters, which will greatly help me process things. Okay, in a second we can see what happens if we do not do that. Okay. My goal here is to count how many times everything happens. Okay, so now I could, for example, print only the value for 7 o'clock. So I'm not going to print the split line, but split line of 0, 1, 2. Okay. Okay, what happened here? Let's see. Oh yeah, as you can see, I messed up the order of the of the parentheses. Okay, and I got a very weird error. That happens quite a lot. Okay, if I mess up something, sometimes the error is very helpful, sometimes it's not. Okay, it's telling me non-type object is not subscriptable because the result of print is actually something called none, so it doesn't return any value. And I was trying to subscript this because I was making this mistake. Let's not make it. Okay, now I have the list of all of the windDirections at 7 o'clock. Okay, and I want to count. You need to count them all, okay? But I'm not going to solve everything here. I'm just going to focus on 7 o'clock. So you probably need another loop here or a map. Just think about it, okay? But here I have already quite a long list of windDirections from 7 o'clock. And I want to count how many times every thing appears. So the first thing that I could do is say, okay, how many windDirections are? So I have W, I have S, I'm just checking here. I have SW, I have what else? N, I have SE, I have E, I have, of course, West, North, Southeast, Southwest, and so on. Okay, which one I'm missing? Northeast, probably Northwest, and I think I'm probably already have all of them here. Okay, so I could define variables for each of them. that would definitely work. So I could say count W, okay? And start with 0. And every time I could check if split line of 2 equals W, then I could add 1 to count, not sound, count W equals count W plus 1, okay, or to make it shorter, count W plus equal 1, which is the same thing, okay? And then I could print the result of that here at the end. And I would know, in this case, that I have 1,901 times with the W counter at 7 o'clock. Okay, so this would definitely work. I could now go on and say, now count east. And this also starts at 0. And here I have an elif. So another branch of alternative. If this split line is not W, but E, then I can count east plus equals 1, and then I print both. Okay, okay. Equals, and I missed the semicolon, okay? So, and in this case, the error was very helpful and was already telling me this. Expected an indented block after elif statement. This is not properly indented, okay? That also happens. So now I know that I have 1,901 instances of W of west wind at 7 o'clock in Zhao Mountain and just 132 of east wind in Zhao Mountain. Once we are done with all the data processing and so on, we are going to actually draw some conclusions from this. And that's part of the exercise. Okay, what can you tell? This is not just about coding. Coding is just a tool here. And what I want you to do is to use that tool to draw some conclusions about the data that we have. What does this mean in terms of wind in Zhao? What can you tell me using your own profile and your own expertise? Okay, but for now, I'm just going to keep coding. I can go on and on and on, but I will have several problems. First one is that this code is going to get very long very fast. And that's going to be very inconvenient, okay? And the second one is that, as we will see, I'm going to miss quite a lot of things. So instead of doing this, I'm going to use a dictionary. First of all, I'm going to turn all of this processing, I'm going to change it a little bit. So then the building of that dictionary becomes a little bit easier. So first thing is I'm going to get rid of these counters and so on. This works, but they are going to be very inefficient and very annoying. So what I'm going to do first is put all of these list of tuples that I'm making, these split lines, into a list, okay? That I have already here. So I'm going to append them at every step, my list. And here I append at the end of the list at every iteration the list of elements that I create at every moment, okay? And here I'm going to just print my list. I mistype this, append instead of append. List append takes no keyword arguments. Yeah, sorry. I don't need to give this a name. Python is thinking there is a name in the append function called splitline. There is not. Okay, so now I have my list of lists. Okay, I want to process the wind directions at every point. So I don't really need the index of every line or the date. So I'm going to slice this list. So I don't want everything. I want just from 2 forward. Okay, position 2 is this one. I want this one, and then everything until, and as I'm not writing anything, until the end. So if I write this, then I have this list that only contain the wind directions for every day, for every record. Okay, so now I have built this wind direction list. Okay, list of tuples. Okay, list. Actually, this is a list of lists. Okay, yeah. I can do this, and I can do this also, transforming them into tuples if I want to. It works very similarly. Okay. Okay. So what I want to do now is process this list of lists in this case into a dictionary. I want to use all of this to create my dictionary. Okay. Sorry, by the way, as we were saying before, this can be done with a simple for in Python, or this can be done using list comprehension. Okay, so let me just put this here. Let me give you a couple of minutes to think about how to do this with a list comprehension. Okay, so we have done this for loop, which will not run in parallel because it's general for loop, but we could make this run in parallel if we used a list comprehension. So advanced students, how do you turn that into a list comprehension? Okay, that will make your code faster in this case. So have a think and see if you can do it. Let's give it 2 minutes. Meanwhile, I'm going to set up for the processing with a dictionary. Okay, let's go. Sorry, probably the thing about the list and the tuples was not super clear. Let me just stop 1 second and make it clearer. What I was asking for here is a list of tuples with every tuple, the date, and this list that I have put here. Okay, so what I was asking you to do is to just group together this thing that we have already added and the date, which is this same thing, but in position 1. Okay, if I do this, I get this list of tuples. In every position, I have first the date and then the list that I already had. Okay, so we can either process that or get rid of this. This is neater because now I know what day I'm talking about, and that helps me during the processing to see that I'm not making mistakes and so on. But that's not completely unavoidable to get the final thing. But let's process from here. And now, first of all, let's do it with a list comprehension. List comprehension is just a simple syntax change to put the for inside of a different type of syntax. Okay, so what we do with a list comprehension is first we name our list, in this case my list, and then we write the square brackets for the to declare that we are creating a list, and then we have the for here in this form. So we would have still the with open, the same with open that we have here with the file and the next. So we still need these two because we need to open the file. And then what do we do at each, what do we do to create the list? Then we are going to be iterating inside of our list comprehension the same thing that we iterated before, okay? So for each line in F. And list comprehensions always work in this way. We have an expression here and then an iterator inside of it, an iterable inside of the list comprehension. And that does exactly the same as the for does, okay? So here I'm going to be adding this thing, this tuple that I have here. I don't need the append because that's already part of the list comprehension. And then I'm going to be adding this at every step. Okay. And I can then print my list also here. Essentially, in this case, the list comprehension is just another way of writing the same loop. But because this is more constrained, because this only works when I'm doing this thing, when I'm doing append at every step, this is faster. This can run in parallel, this cannot. Okay, it's not always faster. Sometimes the optimizations of Python already take care of these kind of things. But in general, if you use things like list comprehension, you will get code that is faster. Okay, so now let's go with the second part. No matter what I was doing here, if I was creating my list with for or with a list comprehension, in any case, I ended up with something like this. And I want to now process that. I want to create a dictionary. I said before, I could just count everything in a different variable. Yeah, that would work, but that would be super, super inefficient. So what I'm going to do now is process every one of my entries in this list of tuples to create a dictionary. So let's create a dictionary. This creates an empty dictionary. This says adict is a variable that will point to a dictionary that at this moment has exactly 0 pairs. There is nothing in my dictionary. And now I'm going to just iterate over my list, okay? If I just say X in my list, I'm going to have one tuple at every position, which is going to be a little bit inconvenient. I'm going to say day and wins in my list. And this is going to put in every instance the date in the day variable and the list of wind direction in the winds variable. Okay. And now what am I going to do? Well, I'm going to I was just checking position 2 from my wind's direction. Sorry, position 0, the first position from my wind's direction, position 2 from the initial line. Because I'm in these examples, I'm only counting things that happen at 7 o'clock in the morning, but you should count all of them. Okay, so you probably need a 4, need some other processing here, but I'm just going to check winds of 0, the first position in winds. Sorry, winds of 0. Winds is a list. Okay, and what am I going to do? I could do the same thing as before. If winds of 0 equals I was saying W, and then have a variable for this and so on. But I can also add this to a dictionary, and I'm going to say whatever is here, a dict of this key takes the value whatever it was before plus 1. Okay, so plus equals 1. I'm going to just want to add 1 to my key and value pair. The key will be whatever is here. If it's a W, if it's an S, if it's whatever it wants to be, and I will add plus 1 to this variable. If I do this just this way, I'm going to have an error. Okay, so key error. Because what I'm doing here is I'm saying, okay, have a look at this a dict of winds of 0, look at this pair, and then add 1 to it. But I'm never creating this pair. So the first time I encounter this, Python goes to my dictionary and says, okay, there should be a key and value pair whose key is W in this case. And it goes to look for it and it's not there. And then it complains, hey, that's not a thing, okay? So I should be a little bit more careful here. So I should check if it's there or not. If my key winds of 0 is in my dictionary, this is the way to check whether or not a key is in my dictionary, then I do what I was saying. Okay. Else, if it's not there, then I create this key and value pair. A dict of my winds of 0 takes the value. Well, it's the first time I encounter it. There is a value 1. Okay. And now I don't have an error, and now I can print what happened with my dictionary. Okay. Have a moment to have a look at these results. Okay. Check them, see what stands out. There are a couple of problems that you should be able to address here. What are the problems here? Well, I have the same results that I had before, luckily, for W and for, was it East, I think? Okay. And I have quite a few of the values that I want. But I also have this, for example. This means that the nothing, the blank space data, the entry is also getting an entry in my dictionary. Okay, this happens because, as I saw in the data, there are many data that doesn't have an entry, and that's interpreted as this empty string value. Okay, so I'm storing those two. And what else? I have southwest, northwest, north, southeast, northeast, south, north. What's this? I have southwest in lowercase. Okay, oh, that's a problem. West in lowercase. West space. Okay, south space. Double south. Or maybe this was southeast. I don't know. Southeast in lowercase. No, northeast in lowercase. Okay. Even more. Let's remember this strip that I had here. that I used to get rid of new line characters. Let's put it back in. If I put it back in, my dictionary now has, okay, that didn't work. Sorry, it didn't work because I only got it out from one of the places. I need to get it out from both of them, or as you can see, it's not going to work. Let's do it again. Okay. So, well, demo mode, I should be having quite a few of new line. Of course, I'm not having them because I'm just visiting winds of 0, and that one doesn't have the new line character. Okay, but if you if I change this to winds of -1 and I go to the last position, and this is something that you will need to do because you will need to address all of the positions in the list. Now here they are. Okay, so in the last position I have lots of things that are just new line character, and things that are W and new line, and things that are SW and new line. Okay, so you should also account for this. Okay, I'm just checking things that happen at 7 o'clock in the morning. 7 o'clock in the morning does not have these new line character problems, but you will have them because you will need to check all of the characters in all of the hours. Okay, so be careful. My point was that you need to find what to do with these characters and with these values. This is not a coding decision. This is a, let's say, design decision. So for example, I would say that we can very quickly get rid of the blank space if I'm not a blank space. And sorry, I can actually make it a little bit cleaner. I can put an if here, for example. If winds of 0 is different from the white space, okay? So from the empty string, sorry, not white space. And then I have all of this inside, and then I don't have that problem anymore. Okay, this is one thing that we can do with those. We have to decide what you want to do. This one looks pretty easy. Okay, going to get rid of it to have a shorter code, but that's something that you probably want to do. I don't know, SW lowercase and uppercase, you might want to just change this thing that you're reading to uppercase always and count this as uppercase because these are very clear what they mean. Some others, spaces, yeah, you can probably use strip if you want. Do whatever you want, explain what you do and why. That's the point, that you make a decision. Maybe we don't exactly agree on the decision you made, but if you justify it, it's going to be okay. Okay, and there are even some cases where it's not clear what was meant. Does SS mean south? Should there be only one S, or was this supposed to be SE because the E is very close to the S in the keyboard, and did someone make a mistake? I don't know. Maybe in these cases where we don't know, we have to get rid of the data. Okay, decide what you want to do, explain it clearly. Okay. Okay, so this is one way to use a dictionary to get rid of these things. And this should get you over this part of task 1 pretty easily. You need 1.4 probably here, but you should be fine. Let me go with some slightly more advanced things here before we finish. Okay, and first of all, I'm just going to do this a little bit more compactly by using a default dict. Okay, default dictionaries allow me to get rid of the annoying if something is already in the dictionary. Basically, when I define a default dict, I can do it like this. I'm going to call this another dict, and I define it by writing the default dict word, which means that my dictionary will have default values. Okay, and here I have to put a function that returns a function that is called when a key is not present. So I need to tell Python what to do when something is not present. In this case, where I want to store integer values, I can just write down lambda : 0. Okay, and that will mean that a 0 will be returned when I call my dictionary with a key that's not present. Okay, these lambda functions are a type of very useful function when I need to make a very quick and dirty function that I just want to call in very narrow type of situation like this one. And you can have more details about them, but just Googling Python lambda functions or by checking these course 3 advanced programming techniques. And here we also have a little bit about lambda functions. Okay. So this means that I have a dictionary, and when a key that it was not in the dictionary is invoked, I put a 0 together with that key. And now I can just do what I was doing before. For my list, okay, and sorry, I'm going to copy all of it, but I'm not going to need all of it. And this is another dictionary, so let's just copy this. I'm going to still go over my list of tuples, okay, and I'm going to do what I said before I wanted to do. Another dict plus equals, sorry, another dict of winds of 0 plus winds, not wind, plus equals 1. And this will already work, okay? And I want to print another dict. Okay, now I have, instead of a dictionary, a default dict, okay, with a function lambda something, okay? So this is the technical definition of what I'm doing, but then I also have the list of value and key and value pairs, okay? And I have the same that I had before, okay? Still have a few minutes. Let's go with the slightly more advanced material. We already did the default dict. Now I want to transform this using a function. Okay. So I can just put this part inside of a function that I called process tuple, for example. I'm going to define my own function, and this function is going to have a definition here. Update the dictionary according to the information in each tuple. Okay, this anytime I make a function, it's a good idea to have some comments like these ones. You can make comments by adding 3 of these semicolons, or by just adding this, but then everything has to be in one line. Okay. And what I want to end up doing is putting this into a function. So let's assume that my function is going to receive a tuple. And a dictionary, dict, and then what this is going to do is just, as I was saying before, I'm going to update my dictionary with the contents of the first position of the tuple, and I'm going to just +1. I'm going to look for the key tuple of 0 in my dictionary, and I'm going to update it at 1 to 8. And then I can just use the same definition that I used before. Okay. What am I doing? At each step, I'm just calling my process tuple function. Okay. Process tuple function here with my tuple as winds. Sorry. Okay. Let's. My tuple should be. I can actually do it like this, for example. I'm going to now not worry about separating this here. I'm just going to call this tuple, and then I'm going to tup and then another dict. But then what I should do is that I'm just calling my function with my tuple and my dictionary at every point. And then what I need to do is this is not tuple of 0, but this is I need to take the thing at every position and then take the first element in my tuple. Sorry, the first element in my tuple, this is the list of wind directions, and then I need to check 0 there. Okay. And now let's print here the result in another dict. Okay, let me check this, and then I will have another go because it was a little bit too quick, probably. Okay, I'm having the same thing before. Okay, so basically what I did here, apart from a mess of explaining it, was just take this and put this thing inside of a function. Okay, this function, instead of receiving this already separated, I iterated over the list of tuples. So I have the date and then the list of wind directions here. And what this does is access the list of wind directions, which is in the second position of the tuple. So it's not the date. And then once I'm in that list of wind directions, I take the first one from 7 o'clock. Okay. Maybe you're thinking, okay, this looks a little bit more complicated than that. And that is totally true. That is, yes, that happens. Why am I doing that? I'm doing that because now I can use a map here. Okay. Maps, another way of making things parallel and making your code quicker. Okay. And we don't have much time in these sessions to get into them, but have a look at these examples about handling data, okay, the managing volcanic eruptions, and this one example using data structures to process data. Okay, and this also includes maps and includes details about what we are doing and how to use maps to make your code faster. So have a look at those. But basically, what I wanted to say here is that now that I have the process tuple function, I can copy it here. Okay, I still need the default dict. I'm just copying everything into the new cell. This should also be here for, let's say, completeness of the code. Every cell should work on its own. Okay, so I need, shut up. I need this. And then I need the process tuple function. Okay. And now I want my map. Okay. In this case, I'm going to have the problem that my dictionary is, when I use a map, I need to call map, I need a function, and I call the function over an iterable, and my iterable in this case will be my list. Okay. But I cannot give parameters to my function, to my process tuple function, apart from what's already in my list. So my list already contains the tuples, so I need to find a different way to pass the dictionary. Okay. So in this case, I'm going to just say a dict equals default dict of lambda something something, as I was saying before. Okay. And this is going to work. Okay. Now I have a map object, and to actually create what I want to see, I need to call it with something, for example, like a list. Okay. This, you have the details in the examples that I mentioned before. And now I can print a dict here, for example. Okay. And I end up with exactly the same thing. What did I do here? I got rid of this variable passing here because this is a global variable respect to this function. Okay, because this has been defined here. This is visible inside of here. In general, what one does, this is again for advanced students, is if I'm doing something to process and I'm defining a function here, I defined my single element processing function inside of the other function. So all its variables, all the variables defined in the big function are visible inside of here. That's what's called sometimes closures in Python. Okay. We will check the example that I mentioned before next week, but you can have a look at it. And this is what we are actually doing here. Okay. Basically, now we got rid of the processing loop for the list using a map, and that's also going to be much faster. Okay. Not finishing this code now. Please have a look and have a go at it. We were saying before, but this function is really shitty. It doesn't have much meat on it, and it does not have much content. Okay, but my point is that here I'm not solving the full problem. I'm only solving the problem of what happens at 7 o'clock. All of these calculations I'm doing and so on are because I'm always checking wins of 0, and I'm checking only the first element in the list of wins. You need to check them all. Okay, so you need a little bit more content here. You need at the very least one for loop. Okay, and that will make this function also a little bit bigger, and that will make the using of the map a little bit more, it will give it a little bit more sense. Okay, so go and check that. Okay. Okay, so I think that's mostly it. Next week, we will answer any questions that you might have. Okay, let me check if there are any questions at this moment, either in Slack or in web class. Okay. And no, at this moment, there are no questions in either one of them. So Let me just wrap this up as we are in our last minutes by saying that this should give you a pretty good handle with task A. Beginner coders, if you're able to solve tasks A and B, you should be fine. You should get a high mark in the assignment. If you can do task A properly, you should also pass probably, but maybe not such a high mark. For more expert coders, I hope to see the comparison of the time with the different ways of doing this using the map and not using it using pandas properly. Okay. Remember, I recommended using stack here and then just count or value cons, and that should not be very difficult, but you should be able to check the difference of time with, we saw how to measure time in past sessions, okay? And then more expert coders, you can have a look at the other tasks about profiler optimization and so on, and using filter and using other filter processing functions, okay? So don't worry if you don't complete anything. I strongly suggest that you try to complete task A 100% as much as you can of task B. If you cannot, if you have questions, ask me, okay? But remember to complete this. This project along with the other two projects are what's going to determine the grades in this subject. So far, you haven't been asking me too many questions, and that's a bit of a problem. Well, not if you already know what to do, if you're already fine, but if you're not, you're going to need to get this figured out by next Monday. Okay, so count on me if you need my help. Happy to provide it. Remember, questions will not come instantaneously, so allow for a little bit of time. Next week, we will have a little bit of a look, as I said before, to some more things about the maps and some of that code. And I will be speaking about what we will do in the second programming project, where we will start image processing. We will also, if need be, answer as many of your questions as necessary. I'm happy to dedicate the whole session to answering your questions, but in case there are not so many questions, we can also do these other things, okay? So that's it. Here is where we finish our session today, and thank you for listening.